All right, good. Hey, everyone, this is Chris Casano. I think we're about 3 minutes after, so probably okay to get started. Do the panelists want to say anything before we get going?
We're
Okay.
good. We just want to thank everybody for joining Push2PROD. We're very excited with the agenda that we have and absolutely delighted to have Cockroach Labs kicking us off first.
Awesome. Thanks, Chris. So again, I'll just quickly introduce myself. I'm your presenter today. My name is Chris Casano. I'm from Cockroach Labs. I'm a solution engineer and been with the company for about a year now. I'm here today to talk to you about how you can deploy Cockroach on Kubernetes. It's a very unique experience in something that Kubernetes has brought us a lot of goodness into the market, and we believe CockroachDB provides a lot of capabilities for your modern applications and being able to scale up and scale out. And I'll walk you through how that works and the uniqueness of the database. I would love to keep this interactive, so do ask questions. As JP mentioned earlier, you can use the Q&A to ask questions. And sometimes we do these webinars, we get hundreds of questions. So if we can't get to every single question, we'll certainly respond and shoot out the answers post the webinar. There will be a demo today as well. So as I get through a handful of slides, I'll demonstrate how we can deploy Cockroach on OpenShift. Okay, great. So let's get going. All right, so just some quick background. Kubernetes has been in the marketplace for a while now. I'm not going to go in depth on Kubernetes, but I will talk about how Cockroach works with Kubernetes. Again, Kubernetes is a pretty unique architecture. It's distributed in nature. It helps your application scale up and scale out. We see a ton of shift in the marketplace of folks moving their applications to Kubernetes. And sometimes where it's left behind is figuring out what to do with the data. There's other services out there. There's a lot of databases historically that have not scaled well into Kubernetes because they've traditionally been more of a monolith type of database or working on single node systems and so forth. So we're going to talk today about how Cockroach lightens that load for you. It makes it easier within the Kubernetes environment to actually have a distributed database within a distributed architecture like Kubernetes. So yeah, let's talk about the database a little bit. What's interesting is that Cockroach is able to spin up nodes in all parts of the world. We can spin up in public clouds, private clouds, on-prem hardware, VMs, Kubernetes, you name it. We're very much hardware agnostic. And because you can spin up all these nodes in different places, you can also connect them all. So you can have a giant cluster that spans the world, just like you could do this with a multi-region Kubernetes setup. So what's interesting about this is that you can actually start getting your data closer to the usage, right? So if you have users in the UK, you can start moving data closer to your users in the UK. And on the flip side, if you have users in California, you can move data closer to the users in California, but all maintain that in one single cluster. And what's also great about that is that because we have a distributed cluster, we can do a lot of interesting things like replication and be able to survive through major outages. So if there's an entire region outage or an availability zone outage, you won't even notice it in Cockroach. Cockroach lives on. So it gives credence to why we call ourselves CockroachDB. Cockroach is pretty hard to kill and is a very resilient insect. And we think the database that we have is very resilient and very hard to kill. And I'll show that in a demonstration today. So yeah, as we get into bringing CockroachDB into Kubernetes, it really allows you to do something unique, right? You have ways that you can do things with multi-cloud or have parts of your infrastructure on-prem or parts of your infrastructure in cloud, and be able to span both of those pieces of infrastructure by just having one cluster that coordinates the data between both. And like I said, we work anywhere. AWS, Azure, Google, OpenStack. We're very much hardware agnostic. So let's quickly just talk about the database, and I'll give you some of the pieces of why it's unique and important for Kubernetes, especially for modern applications. So first, it brings you a relational experience. So if you're very familiar with working relational databases, it's the same type of experience. It's SQL enabled. We use the Postgres wire protocol. The dialect is very similar to Postgres. So we find a lot of customers that are having trouble with scaling up Postgres, or have resiliency problems with Postgres, or want to be able to bring data closer to users, or if you have sharding issues with Postgres or other databases, relational databases, we make this really easy within CockroachDB. In fact, talking about sharding, we do all that sharding for you. Anytime you're going to do a shard of relational database, it's a series of gymnastics and operations that you have to do to make it work. It's been done for for a number of years, and people are used to doing it, but it's still an operational headache, and we make it really simple and easy within Cockroach. And I'll show you some of that today. The last two things of why folks choose Cockroach is really these two things. I'm going to highlight resiliency as the most important one. Because we're horizontally distributed, we can allow for node failures within availability zones, even entire regions to go out, and the database lives on. So we're purpose built for high availability. And like I mentioned before, because we can distribute load across the world, we can be really granular about where we want data to be located, so that it's closer to the users to have very low latency for those users that are accessing the data. And lastly, another reason why folks choose Cockroach is because of our consistency. So we use serializable isolation, which, if you're a database guru, is pretty much the strongest form of isolation within a database. So you can always ensure your transactions are consistent. If we've learned anything over the past 10 or 20 years or so, the advent of NoSQL database has been terrific in being able to allow us to scale and do a lot of flexible things with databases, especially as far as having schema-less representations of data. But it definitely has cost us a little bit on the consistency side. So this is one thing that Cockroach brought back into the forefront. Instead of having all of your application doing all the consistency logic, we could push that back down into the database and allow the database just to be consistent, so that you have accuracy within your data no matter where you're accessing it from. Okay, so folks will typically ask, well, how do you do this? What's the magic in being able to horizontally scale and ensure that you have consistency and replication, all these things? And it really comes down to how we use Raft and replication within the database. When you take a table and you load data into that table within Cockroach, what we'll do is we'll actually automatically shard that data. We call these shards ranges. They're typically anywhere from 64 megabytes to 512 megabytes. And as you start loading data, we'll create more shards for you. All the data that is lexicographically sorted within these ranges, so it allows us to do range scans really quickly. And each of these ranges are part of what we call a Raft group. And what that allows us to do is to make sure that we have consensus within all the replicas, to make sure that data is consistent. In each of these Raft groups, you'll have a leaseholder that you see here on the right-hand side. And that leaseholder is really responsible for the reads and writes that are happening within that Raft group. And what's great about this is that you can increase the number of replicas, right? And typically you would do that if you want more resiliency within the database. So you can increase that, that replicas to 5, to 7, to 9. The trade-off will be that you now have more replicas that you have to coordinate. The way we do transactions is all through quorum. Right. So anytime you're going to do a transaction, you have to have 2 of the 3 of the replicas to agree on the transaction in order to commit the change. So if you do have more replicas, you do have a little bit more latency that you're going to be adding to those transactions. But we've done a terrific amount of engineering with parallel commits and a series of other engineering enablements that have been talked about at SIGMOD, has been talked about in universities as far as the changes that we've added into the database to do horizontal scaling and having strong transactional consistency. So this is what makes the database hum, is that we have all these ranges working in conjunction with each other. There's a transaction layer on top of them that helps coordinate all of the replication and the transactions within the database, but this is the magic and what makes it all happen. And what's great about having replicas is being able to disperse them across the cluster so that you can be resilient, right? So one thing that we're really good at doing is Cockroach is very aware of itself and where the nodes are located. So what rack is it located on? What availability zone? What region? And because it's aware of, of its own locality of where the nodes are, is very good at rebalancing the cluster for you. So this is something you don't have to do at all. Cockroach will do it automatically for you. So as soon as you load data into the system, ranges get created, those RAF groups get created, and then data is dispersed in a very balanced manner. So you can see here, the examples that I have here, the range from Carl and Jack was dispersed. Now Lady to Petey is being dispersed, and these are all names of dogs if you're not familiar with the names. And the same thing, the last range that has Pine Top to Z is dispersed on the cluster. And you can see all of these ranges are ordered by the primary key lexicographically, and that's how they're dispersed into the cluster. Now, what's also interesting about this is that we have a lot of heuristics built into the database to know where the load is coming from. So if we have a geographical cluster set up and we get a lot of traffic coming in from UK users, for users in the in the UK, they're accessing maybe Carl to Jack, what we'll actually do is start moving those ranges closer to the UK region. That way you lower the latency for any of the queries that are happening from your UK users. So there's nothing you have to do here. By default, we'll actually use heuristics to move the data accordingly so that you can have low latency with your queries. On top of that, you can be really specific if you want to pin data in certain regions. So we allow you to do that as well. There's a special feature we have called geopartitioning that allows you to actually be very specific or granular where you want to land data. It's been especially useful out in the EU for GDPR rules where you need to keep data in specific localities for compliance purposes. Oh, and that actually got me into my next slide. So yeah, so this is kind of describes how you can do geopartitioning, right? So if I have Carl and Z that are in the UK, this range of data is in the UK, I can say, hey, make sure that this data always stays within the UK region. I actually don't want it to replicate anywhere else. And maybe I'm okay with that for the GDPR rules. There's other times you don't want that. There's other times you might want the data to be dispersed across all of the other regions across the world. Maybe because it's referential data, maybe because you want better survivability in case of an outage. Either regard, we give you a lot of flexibility as far as how you want to work with the data so that you can lower latency for queries. And actually, I'll just leave you another thought here. One customer brought this to describe this in a really elegant way, is that Cockroach is kind of like a CDN, like content delivery network, but it has transactions. So that's what kind of makes us unique in this kind of setting. All right, so let's just talk quickly about rebalancing. Rebalancing is really simple for us. Like as I explained before, Cockroach is very self-aware of itself and knows where the nodes are located. There are times you might want to scale up. You have peak loads, or maybe you're a retailer and you have a lot of seasonality, or some of the things that are happening, with the world economy today, where things can get really bursty. Cockroach is great at being able to scale up and scale down as needed. So one thing you can do is you can add a node into the cluster. And what will happen is that the cluster will be aware that, hey, a new node is here. I can start it without even data being in that node. It will start serving traffic. And as the cluster becomes aware of that node, it will start balancing the cluster out and moving replicas into that new node. The same thing goes if you have a failure. So let's just say you have a node that goes out, and we're going to show this today in the demo. Let's just say a node goes out within the cluster. The cluster, again, is very self-aware and patient about failures. So if it sees a failure or a node is down, the great thing is that Cockroach continues on. Because we have other replicas dispersed within the database, we can continue to serve query requests that are coming in, both writes and reads and writes. So what will happen is that Cockroach will wait a few minutes to see if this node is going to come back online. If not, what it will do is it will start up-replicating the replicas across other nodes to make sure that it's balanced and that we have a fair amount of replicas for our RAF groups. To ensure that we have resiliency in case of another failure, and also make sure that we're balanced with data. Okay, so let's talk maybe quickly about how this works for Kubernetes, and then I'll jump right into the demo. So the way that we work with Kubernetes is pretty straightforward. We make great use of stateful sets. If you're not familiar with stateful sets, maybe to explain this in a simple form, if you think about Kubernetes, has been working great for years with stateless apps. So being able to bring a database onto Kubernetes is, a few years ago without stateful sets was a kind of a difficult thing to do. But with the advent of stateful sets, which just came out, I've forgotten which version, the 1.15 or 14 version. I don't remember offhand. It's somewhat recent, not brand new, not it didn't come out yesterday, but it's been here for a while, and we've made great use of this for using persistent volume claims for the database storage, as well as having fixed networking for each of the pods. So what that allows you to do is, if a pod does go down, the persistent volume stays on, so that if you spin up that node again, it can reattach to its storage, and you're off and healthy and ready to go. And if you think about how Cockroach is architected and how we can horizontally scale and add more nodes, and if you think about Kubernetes, it's very aware about the pods that that go down, where a container gets stops behaving the way it's supposed to, and it's very easy to delete a pod and another one spins up. And Cockroach, thrives in that type of environment. That's what we're meant to do, is be able to handle failures and spin up new pods for scale out. So how we do this is we make great use of stateful sets. I'll show you through a little bit of this today. Explain about the storage, and then operators. So one thing that we are been working great on is having a operator available within Kubernetes. I'm going to kind of show some of that today, something that we've done in the community. We are going to eventually open source our operator that you can use within OpenShift, and then you'll be able to use it in other flavors of Kubernetes as well. But I'll show you kind of our community version that we've been working on to date. Okay, that gets to the demo. Before I jump into the demo, let me just see, is there any questions out there that in the chat that need to get answered?
Yeah, Chris, it seems like we got a few here. The first question is, how does CockroachDB differ from Postgres and MySQL?
Okay, great question. So the biggest differentiator is our ability to scale out horizontally. So the fact that we shard all the data for you makes it really easy as far as how you would have to do this within Postgres and MySQL. So in Postgres and MySQL, you have to coordinate how you're going to shard the databases. You'd have to coordinate within your applications which shard to connect to. You have to coordinate how you're going to do all the backups across all those shards. Within Cockroach, we shard the data automatically for you. You take one backup across all the nodes in the cluster with Cockroach, and it's a distributed backup that allows you to pull data from all the nodes into a shared storage location for really simple and easy backup. On the app development side, there's really nothing you have to do as far as pointing to the shard. You just point to a load balancer. That load balancer points to all the nodes in the database, and the connectivity is that easy. So you can use the Postgres drivers that are out there to connect to Cockroach. It's to any application developer, they don't even know. You can be in a 100-node cluster. The app developer wouldn't even have to know. All they know is they're connecting to a database, which makes the experience really simple. That's probably the biggest takeaway. There's other nuances, but I think that's probably the biggest differentiator.
Nice. We got one more here. Does Terraform support CockroachDB?
Yeah, absolutely. So we use Terraform internally. We have a lot of customers that use Terraform. We have been working on a Terraform provider. It's not out there yet, but we do have a lot of customers using Terraform. And with Kubernetes, we have a lot of folks that have been using Pulumi. That's another one that's been coming up rather recently. And we use Pulumi internally as well. Great questions. Do we have any other ones out there? Throw your best tomatoes if you can.
I think we have one question come in, but I think you're about to cover it here. So hang tight and we'll get right to it.
Okay. Sounds good. So let's go to the demo. And I'm going to show you, a really simple setup. So we're going to deploy Cockroach on OpenShift. We'll deploy a simple 3-node cluster. So you can see how the database is set up. I'll walk you through our admin UI and a little bit about how this works within OpenShift. We're going to run a quick little workload. So we'll just send, some data into the database, have some queries happening, some selects, updates, deletes. And while the database is running, we're going to test resilience. So I'm actually going to kill one of the pods, and you'll see, the database continue to do its work and service requests and so forth. And then Kubernetes will, like magic, spin up that pod again. That pod will reconnect back to the cluster and again, continue to serve traffic. Okay. All right. So let's go. Let me jump out of this. Okay, so if you're using, is my screen coming up okay?
Yep, we can see it.
I need to make it bigger.
Yeah, if you can expand it just a little bit so we can see a little bit more.
Okay, so
that looks great.
Awesome. Let me just get rid of my bookmarks too, so we have more screen to see. Okay, so if I'm in OpenShift or CRC, if you come into the operator hub, you can do a search for Cockroach. There's a couple of different options out there. The one I'm doing is the one that's not part of the marketplace or not part of the community. It's this one here. This is something that some folks on my team and as well as engineering has built. We have another separate operator. If you want to take a look at it, it's in our GitHub repo. Right, so if you go to CockroachDB, Cockroach Operator, there's one out there. It's still being worked upon. If you want to contribute to it, great. If you want to see how it works, you can see it here. And eventually we will open source this for the general public. So stay tuned, it is coming. But yeah, the operator that I'm using today is here. And what this will do is this will install the operator. If you want to go see some of the details here, you can. I don't know if we need to get into all of it, but it is using stateful sets for setting up the service. And you'll see that I have, it creates 2 different services here for, DNS and load balancing. It also creates the pods that you can see here. This is our 3-node cluster that has been set up within the environment. And of course, you can always do, database demos are always fun because there's always a command line involved. But you can use the command line to go see the pods that are running, and you can see here I have the 3 databases set up. I have the admin UI for Cockroach port forwarded. Let me see if I can. Sorry, this Zoom toolbar is getting in my way. But here's kind of an older version of the admin UI. But this again shows you have 3 live nodes. Here are the nodes here. I can see that there's not much going on in the cluster right now. You can see that I don't have any queries running. That's going to change in a little bit. But the admin UI gives you a lot of information about the metrics that are happening on the cluster. The typical question that will come up is, can you export out those metrics? And we absolutely can. We have everything that you see in the admin UI has REST API endpoints, and we can shoot all those metrics over to tools like Prometheus or other metric collection tools that enterprises typically like, so that you can do alerting and monitoring on the information. Here we can also see some of the databases that are in the database, and also some of the statements that are running on the database as well. So what I'm going to do is, right now we have a 3-node cluster. Everything's live and healthy. We have our 3 nodes here. What we're going to do is I'm going to run a workload. Let me just make sure I got the right command here. Yep. So what I'm going to do is I'm going to kick off, if for folks that have not seen OpenShift, so OC is very much similar to how you use kubectl, kubectl, kubectl. It's the OC is basically a wrapper of kubectl commands, and that, OC and kubectl, all those things. It's a Kubernetes command line interface so that you can interact with, Kubernetes. And in this case, what I'm going to do is I'm going to spin up a Cockroach client. And this is going to run a workload. So what's really neat about Cockroach is that we supply workloads within the database. So if you want to do a sniff test in your environment to see how the environment's working, are you getting good IOPS, are you getting good CPU usage, and so forth, you can spin up these workloads just to sniff test your environment. All right, so I'm going to kick this off, and this will just take just a few seconds or so. And what we'll see some metrics coming in the cluster where things are running. So this will just take a minute. And once this gets running, we'll let it run for a little bit. I'll show you around the admin UI of where you can see things happen, and then we'll go ahead and kill a node. Okay, so you can see things are starting to light up just a little bit. So we can see the number of SQL queries have gone up. We have a couple of selects and inserts happening. We can see the queries per second is pretty small. It's only about 30 queries per second. I am running this on my local machine, but if we were on a much bigger OpenShift environment, we could scale this up tremendously. And we have a lot of benchmarks out there. If you go to our documentation and look at the TPC-C benchmarks that we have out there, we show how we benchmark TPC-C 100,000 warehouses, which I think we utilized about 81 nodes to do that particular work. So, like I mentioned before, Cockroach scales out really well for high volume workloads, and we have, like I mentioned, you can always see how that TPC benchmark works within our documentation. Okay, so this is great. We got our workload going. What we're going to do now is I'm going to show you how to go to remove a pod. So you can see we have 3 nodes that are live, and come over here and say OC get pods, see which ones are running. We'll do OC delete. We'll do this one. Oh, I have to say delete pod. Okay, and that pod's getting deleted. And so what you'll see here in the interface is that the number of nodes is actually going to go down. Yep, there we go. So we have one suspect node that was detected as being down. And you'll notice that the metrics are still continuing, right? We still are handling the workload, even though a particular node is down. Now, in just a minute, Kubernetes is going to realize, hey, I have a node down. Oh, it already did. And the stateful set that we've applied is going to spin up that container again. That container will connect back to the cluster. It will make sure the data is in sync, and off we go, and we're off and running. So you can see here really quickly that it's, like I said, it's a very resilient database. You can kill nodes or pods within Cockroach, and the database can continue to service requests. It's not easy for other traditional relational technologies to be able to do this within Kubernetes. With that being said, is there any other questions so far that are coming through the chat?
We do. Kind of a question here is about security. Wondering if you could elaborate more on security and how CockroachDB handles that.
Yeah, great question. So we have security on a number of fronts. So we have wire encryption with the nodes. So you can set up TLS or wire encryption for the nodes. It's a really straightforward process. In Kubernetes, depending on what flavor of Kubernetes you're using, there's different ways that you can set up a certificate authority and then apply the certs that you created into Kubernetes. And like I said, create wire encryption between all the different nodes. There's also data at rest encryption. So anytime you're spinning up a node, you can say, hey, the storage for this particular node, make sure you encrypt the store. You can do that as well. We have encrypted backups. So anytime you're going to back up to cloud storage or to a shared storage directory, you can pass in a passphrase that will encrypt the backups for you. We also have role-based access control that's available in the database. So, basically saying, hey, this this user has these roles, has select, delete, insert, update privileges on these tables or databases. So very similar to how you have RBAC and Postgres, we have RBAC within the database. Let me see if there's anything else I'm missing on the security side. There's auditing. You can audit data as well. We also have, in the GDPR scenario, we have query replication reports that you can show compliance groups to say, hey, this data has never left this particular region, and we have reports that will show you that. Trying to think what else. Hopefully I cover the gamut of security there, but let me know if not. Any other questions? Oh, this is a pretty quiet group today. Okay, not a problem. Well, that about takes me just about to the end of the demonstration. One thing I didn't show today in the database is being able to scale up. So you can use things like, kubectl, kubectl, OC, any one of those Kubernetes command line tools. You can use the scale command there to actually scale up the number of nodes, or you can modify the stateful set to increase the number of replicas, but it's a pretty straightforward process. So, just to kind of, I guess, get to more of a wrap up here. Like I mentioned, we are, Cockroach fits Kubernetes, the Kubernetes environment really well. The way Kubernetes handles containers and pods is very much how Cockroach behaves in general. We are a distributed architecture, just like Kubernetes. We work great with containers. That's probably one thing I didn't highlight. We just have a single container. We have a single binary and a single container that you can utilize. And that, a lot of other architectures, they have master worker setups. For us, we're just a single atomic unit, a shared nothing architecture. Every container is a gateway into the entire cluster. So it's a really simple, elegant setup for distributing into Kubernetes. And the container itself is really small. It's only about 100 megs or so. So yeah, sorry, went off a little sidebar there, but like I mentioned, works great with Kubernetes, especially for if you need to do multi-region types of applications where you need to bring data closer to end users and still maintain one instance of the database. And again, you can be very granular with that geo-partitioning I mentioned before, as far as where you want to pin data into certain locations. And yeah, so if you look at some of the thought leadership out in the marketplace, especially with Kelsey Hightower, he's had some great posts and conversations with us about where we fit. So if you want to get more information from the thought leadership out in the marketplace, you can look at what Kelsey Hightower has talked about with Cockroach. And if you're looking to learn more, we have a ton of great content. We do have our own bootcamp. One thing that's not highlighted here is that we actually have our own free training on Cockroach University. So if you go to university.cockroachlabs.com, there is a bunch of free training where you can ramp up on the database really quickly. And there really are some great materials there. The documentation is fantastic. It's world-class documentation. Everything that you can possibly want to find out, we typically have in our docs. If not, we get it out there pretty quickly. We have a ton of video podcasts, so this isn't the only Kubernetes webinar that we've done before. We've done a bunch of them, so do check our website if you want to learn a little bit more about how else other things that we can do with Kubernetes. And we've had a bunch of terrific blog posts that all trend on Hacker News and other places, so they're great resources to check out. Maybe I'll pause one more time to see if there's any other questions.
Yeah, it looks like we have a few come in here now.
All right.
So this question is always a tricky question, but what does migration typically look like? The example given here was like, what does a migration look like from Postgres to CockroachDB? But I wonder if there was more like in general that we could cover that.
Yeah, absolutely. Great question. So we are making this easy and easier day by day. It's pretty straightforward. We actually have a document out there in our documentation that says how you can migrate from Postgres. So yeah, you can use pgdump to import a schema. Now, not every single object within Postgres will migrate. So there's things like stored procedures and triggers that we actually don't support on the CockroachDB side. And when we've looked at modern applications, a lot of modern applications are using the logic that you typically put in stored procedures into microservices. So the request does come up, hey, are you going to support stored procedures? Maybe in time, but right now we're following what the market's doing, especially for modern applications. And so that's one thing that wouldn't migrate, but typically with the modern apps that you're looking out there, is usually a different fashion of how you can use stored procedures within microservices. You will notice, so there's definitely a couple objects that, from Postgres that won't migrate, but the dialect is really similar. There are a few things that, where you might have some dialect changes that might not translate to Cockroach, but for the most part, a lot of the dialect is pretty similar. For MySQL is pretty similar. The dialect is not as strong as it is from Postgres, but it's a pretty similar type of path as far as how you migrate. And then, from other databases as well, if you're migrating from a relational database, the pattern is pretty straightforward. If you're coming from a NoSQL database or a document store, the pattern is much different, and those migrations do take longer, right? So if you're migrating from Mongo, and we do have customers that are doing that, you're moving from APIs to SQL, right? So there's a little bit of changes that you'd have to do in your application. Folks are doing it because they love the resiliency within Cockroach. They love, being able to deploy in Kubernetes. They love being able to have locality within the database and having strong consistency. So that usually dictates, what, you as a customer or you as a technical user need to fulfill for your particular use case. And, migrations do take planning, but coming from the relational technologies, those will migrate a bit easier than coming from the NoSQL world.
Yeah, so there's another question that came in here about replication. You talked about how data is replicated across regions based on where you most access your data. There was just a clarifying question of what if one set of data is accessed frequently in say UK and another say in Southeast Asia?
Oh, great question. So we have an awesome pattern within Cockroach called follower reads. It's worth listening to or reading up on. So what we can do if we have, data that's highly accessed in UK and, the example was in South America? Was that?
It was, one was in UK and the other one was in Southeast Asia.
Oh, Southeast Asia. Okay. So yeah, if you need to have data in both places, what you can do with Cockroach is that you can make sure that the data is replicating in both regions. And then we have a pattern called follower reads. And what this allows you to do is that you can read data from replicas. Typically what will happen is anytime you're going to do a read or write, it's going to go through the leaseholder, which we talked about earlier. So let's go back to this slide. Typically your read and write is always going to go through that leaseholder. They're the coordinator for all reads and writes. But if you want to have other regions be able to read from those replicas and not go through the leaseholder, we allow you to do this through a pattern called follower reads. And what you're doing is basically you're allowing the users in Southeast Asia to say, hey, listen, read from a local replica. The only caveat there is that you'd have to do a 5-second stale read, right? So it's a 5-second stale read from data in the past. Now, if you think about it, right, you have data in the UK and Southeast Asia. I'm not sure what the latency for the speed of light is between the two, but it's pretty significant. And if you're only asking your users to take about a 5-second penalty to read data locally, most folks will take that benefit as far as just being able to read the data locally. So again, it's called follower reads. I'll show you in our docs where that is. So typically this is used, for read-heavy type of applications. And if you're, like I said, if you're okay taking according to our documentation, a 4.8-second stale read, then this is a great pattern for you. Any other questions, JP?
Yeah, There's one about like, does Cockroach require separate clusters from applications and clusters in the cloud?
It depends how you want to work, right? So, you know, a lot of folks tend to want to package, you know, or send a database with a microservice. Cockroach works great in that nature. Like if you want us to be really close to the microservice and work within Kubernetes, we are perfectly fine for that particular pattern. And you can have multiple databases within a cluster. So sometimes you might have, you know, a couple different services that might want to connect to one Cockroach cluster. You can do that as well. You know, we don't have the concept of strong multi-tenancy within Cockroach yet, but you can serve multiple databases through Cockroach depending on what you're trying to do. So that microservice pattern works great. Additionally, you could have a little bit more of the monolith where you just want to set up a database within cloud infrastructure. This is very common as well. We work great within the cloud. You can spin us up in AWS, Azure, DigitalOcean, you name it, GCP. You can even use us within those cloud provider Kubernetes services as well. And that's fine as a typical pattern as well.
One final question here. I know there's been recently been a lot of talk about V-tests. Can we deploy in a V-test cluster?
A V-test. Not sure what V-test is. Is that sounds like a VMware?
Extension off MySQL.
Oh, a V-test cluster. I'm not sure what that is.
Yeah, for this question too, feel free always, if you have any additional questions, feel free to join our community Slack, and you can chat directly with our CockroachDB community as well as our engineers. A link should be in the chat.
Actually, I think maybe the question was it Vitess or Vitess? Vitess, like the database, VITESS?
VITESS.
Yeah, okay. So yeah, I would say Vitess is probably a bit of a competitor to Cockroach. You know, they're a Kubernetes deployed database that's, I believe, has more MySQL roots. We're a little bit different than them. You know, I don't know if we want to get into all the bits and pieces to the differentiators, but they are, I would say they're more of a competitor to Cockroach as opposed to deploying Cockroach on Vitess.
Yep, that's all the questions we have, Chris.
Okay. Awesome. I really thank you for your time today. It's been great chatting with you. I appreciate all the great questions. And if you want to actually do this demo yourself, I have a link in my my GitHub page. You can see it here. Oops. So if you go to my my GitHub handle, just Chris Casano, there's a project there called Cockroach OpenShift, and you can repeat the same demo if you wanted to on your own. Cool. Thank you very much.
Awesome. Thank you so much, Chris.
And thanks to Cockroach Labs for joining us today. We hope to see everybody on the next session with Instana, starting in about 13 minutes. If you do need your unique join link, head over to turbonomic.com/push2prod. You can register and get your link there. Chris, thanks again. We'll see you all soon.
Thank you, everyone.